Alright guys, alright, for your warm-up for today, hopefully you have written it down, and again, I'm making this video so you can go back and reference it. For this problem, it says, given the following polynomial, use the rational root theorem to list all the possible rational roots. I'm going to stop right there because that is reviewing what we did yesterday. So, in pre-calc, in college algebra, there is a theorem, and all a theorem is a rule, it's a law, and so what we call it is the rational root theorem. And what the rational root theorem does is it gives you a list of possible solutions. And the reason why I underline this word possible, guys, is because this list does not give you the answers directly. All it does is give you a possible list of numbers to pick from. Now, in reality, guys, because of the calculator, we're going to use our calculator to help us get some of our answers. But again, when you go off to a major university, most of those schools will not let you use a graphing calculator. So that's why we have to use the rational root theorem to help us get a list of possible solutions. But before we do that, I just want to go back and look at this polynomial. If you notice, the degree of this polynomial is a 4. So I'm going to put that. My degree is 4. What that means is very important. I know beyond a shadow of a doubt that I will have, there's no question about that, I will have 4 answers. The question remains what those 4 answers are. And so that's what we're going to be doing here, solving this. Well, the rational root theorem, the way you get your list of possible solutions is something called your P's over your Q's. And what you do is the last number, it doesn't care about the sign, the last number is P. The first number, in this case, is understood 1. The first number is Q. So that's your value for P, and that you ignore the sign. There's a reason why. I'll tell you that in a second. So I don't care that says -4. You don't worry about the sign. It's just 4. So you do your P's over Q's, so you put 4 over 1. What you do next is you list the factors of each one of those. So factors of 4, well, what multiplies to give you 4, would be 1 times 4 and 2 times 2. So those are my factors of 4, and then the factors of 1 was just a 1. And so once you got this, then we're going to make combinations of those numbers. So 1 over 1 is 1, 2 over 1 is 2, and 4 over 1 is 4. And then the only thing you got to do at the end is put plus or minus. So this is my list of possible solutions. But I want you to understand, guys, that those are not that doesn't mean those are my answers. That's just a list of possible numbers to pick from. And in reality, you actually have 6 choices here. Because if you write this out, you've got +1, +2, +4, but you've also got -1, -2, and -4. And so this is my list of possible solutions, my possible rational solutions. The reason I say rational is because, and why it's called the rational root theorem, is because this list does not take into account irrational numbers or imaginary numbers. So I might, of those 4 answers, guys, I have no idea if they're all real, or if some of them are imaginary, or some of them are rational or irrational, but this is just a list of possible rational zeros. Now, if I did not have a graphing calculator, I would have to test out each one of these with synthetic division and hopefully get a remainder of 0. If I get a remainder of 0, that means that that's one of my answers. But thankfully, we don't have to do that because we've got our graphing calculator. But again, if you didn't have a graphing calculator, there's no way around it. You'd have to test each one and hopefully get a remainder of 0, and that would be one of your answers. But we have our graphing calculator, so I'm going to minimize this, and I'm going to open up my graphing calculator. And what I have here is I've got my graph ready. So here's what you type in. Just type in that function. So I'm going to have x to the 4, and then go over, plus 4x to the 3rd, then go over, plus 3x squared, and then minus 4x, and then minus 4. And so if you type that in, hopefully hit enter, this is the image that you should get. It should be that polynomial. Now, I know that that's what my graph looks like, and it looks like it's doing a lot of stuff, but remember, whenever you're solving a polynomial, what you're looking for are the x-intercepts. Well, if you look at the graph, you'll notice that this graph, it crosses the x-axis 3 times, right? Wait, no, 1, 2. It crosses it 3 times. 1, 2, and 3. Right there. 1, 2, and 3. And so where does it cross the x-axis? It touches it here at 1. It also touches it here, crosses it here at -1. And then it doesn't cross, but it touches right there at -2. And then this is very important, guys. It doesn't cross, it touches. This is what we call a double root. And so that means the -2 shows up twice. And so even though it only looks like it hits it 3 times, this is a double root. So I've actually got all 4 of my answers by just looking at the graph. Here are my 4 answers. I'd have +1, that's one of my answers. I'd have -1, that's another one of my answers. And then I'd have -2, but it shows up twice because it's a double root. And so that will be my answer for that problem. Alright, so going back to our PowerPoint right here, your essential question for today, what I'm trying to do is I'm trying to go back everything that we've learned thus far in this unit, so even prior to yesterday. So here are some topics that we covered yesterday. Rational root theorem and Descartes' rules of signs. That's what we did yesterday. Now before that, we did synthetic division, completing the square, and quadratic formula. And so we're going to tie all this together, and we're going to use all that information to help us solve problems that look like this. So go ahead and take a second, and if you want to in the video, write it down. And you got x cubed minus 4x squared plus x plus 2. Now, I'm going to go through all the steps with you, and then some of y'all might want to skip some steps, but I'm going to go through all the steps with you. So here's the thing. It gives me this polynomial, and the first thing I look at it is the degree. So my degree is 3 right there, which is very important because if my degree is 3, I know beyond a shadow of a doubt I'm going to have 3 answers. I have no idea what those answers are. I don't, but I'm going to try and find them, and that's what I'm going to do now. So because let's say I don't want to use my graphing calculator, what the first step to do is to do that rational root theorem. And in other words, do your P's over Q's. Get a list of possible numbers to try. So in this case, my value for P is 2, and my value for Q is 1. And so my value for P is 2 over 1. Then you list factors of those numbers. All right, so factors of 2 would be 1 and 2. Factors of 1 would be 1. And then just make your combination of numbers. So 1 over 1 is 1, 2 over 1 is 2, and then just don't forget to put plus or minus in front. So this is my list of possible, let me put that, possible rational zeros. And I'm going to write them out for you again so you can see them. So here's my possible list. +1, +2, -1, -2. So that's my possible list. Now, let's say I had my graphing calculator. What I would do next is I would just plug this into my graphing calculator, and I try to use my graphing calculator to help me get one of my answers. But let's say I don't. Let's say you're in one of those classes in college where you don't get to use a graphing calculator. What you would do is you would have to pick one of these numbers to test. So I'm going to let Brendan pick one. 1, 2, -1, or -2. Which number do you want me to try? 2. Why not? All right, so I'm going to test out 2. All right, so the way we test it out is with synthetic division. And so you see I put the little 2 in the box. And so now I'm going to put down my coefficients from my polynomial. So you see that's a 1, so put down a 1, -4, +1, +2. And so we're going to do synthetic division. Now, here's how you'll know if it's an answer. You'll know if it's an answer if you get a remainder of 0. So here's synthetic division. Bring down the first number, then multiply. 1 times 2, 2. -4 plus 2 is -2. 2 times -4, 2 times -2 is -4. -4 plus 1 is -3. -3 times 2 is -6. My remainder here is -4. So I can go ahead and know, is 2 a solution? No. So I could just throw that one out. All right. So let's try. I'm going to just try 1. I'm going to try 1. I'm going to see if that works. So I'm going to try 1. 1, -4, 1, and 2. So I'm going to just do it over again. So 1, bring down the 1. 1 times 1 is 1. -3, that's -3. Oh, I think I got one. 1 minus 3 is -2. -2 times 1 is -2. And my remainder is 0. Which means, but beyond a shadow of a doubt, one of my 3 answers is 1. So that's one of my answers. Okay? Now, here's the thing. If you were to graph this, I want to prove it to you. So I'm going to minimize this for a second, and I'm going to type in that function into the graphing calculator. So let me prove it to you for a second. I'm going to hit Tab. I'm going to go up. I'm going to clear this out. And then I'm going to type in my function, which is x cubed, so x cubed, and then minus 4x squared, and then plus x, and then plus 2. And look at the graph that we get. We get this graph right here. And if you notice, how many times does that graph cross the x-axis? 1, 2, 3. Now, if you notice, I don't really know what that number is. It's somewhere between 0 and negative 1. I also don't know what that number is. It's somewhere between 3 and 4. But beyond a shadow of a doubt, what do I know one of my answers is right there? Has to be 1. That's right. Yeah. So again, if you did not have a graphing calculator, this is the method that you would have to use to find it. You would have to do synthetic division and make sure you verify. Now, here's the thing. Once you got one of your answers, what's left behind, y'all see this 1, negative 3, negative 2. Go back and look at the original polynomial. The original polynomial was a degree 3. When you do synthetic division, it depresses your polynomial, which means it goes down a level. So if you start off with a degree 3, when you depress that, what's this new degree going to be if you go down by 1? Degree, yeah, you go down by 1, it'd be 2. So this is now a quadratic equation, and which means I can use the quadratic formula. So this is A, this is B, and that's C. So that's why everything that you've learned in math thus far, we're tying it together in order to use it for this one problem. And so now what I'm going to do is, that's A. A is 1, B is negative 3, and C is negative 2. Well, if I did, you mean on the negative 1 and the negative 2? You know what? Since we looked at the graph, I bet if we did synthetic division on these two, it wouldn't give us a remainder of 0. Because if you look at the graph, it didn't cross the x-axis at those two places, so that's why it wouldn't be. All right, what you got here? Okay, all right, so a depressed polynomial, that's a big word in math that says whatever your original polynomial, the degree was, whatever that original degree is, a depressed polynomial is always 1 degree less. So we start off with a degree 3, so what's 1 degree less than 3? 2. And so that's why this is a degree 3. The depressed polynomial, after you do synthetic division, is a degree 2. And if you remember from 10th grade, degree 2 is a quadratic, which means we can use the quadratic formula on it, A, B, and C. All right, and so let me write down the quadratic formula for you so you can remember it. All right, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's my quadratic formula. And so we're just going to substitute these three values into that formula. So negative b, well, b is already negative 3, so that means it's going to be positive 3 plus or minus, and then you're going to have negative 3 squared minus 4 times 1 times negative 2 all over 2 times 1. So that's just plugging it into the formula. Now, here's the trick, guys. You cannot type this whole thing into your calculator. It doesn't work like that. You cannot, because there's no plus or minus on your calculator. But what you can type in, you can type in the discriminant. So you see this part that I'm circling right here in red? You can type that into the calculator. And so I'd have 3 plus or minus the square root of over 2. So type this into the calculator. You should get 9 plus 8. So if you type that into the calculator, it should give you 17. And so in reality, those are my two answers. Well, first of all, you always have to check yourself. Can I simplify radical 17? No. So these are my two answers. It doesn't look like it, but they are. Because my two answers would be 3 plus radical 17 over 2 and 3 minus radical 17 over 2. And these would be my three answers right there. So for this one, it was more involved. You had to do rational root theorem, you had to do synthetic division, and then you had to do quadratic formula. But then you got your three answers, and that's how you would do it. I'm really going to try not to use the graphing calculator, but sometimes I might have to. So that's it. But that's my answer for that one. And I'm going to take a look at this one. It's 2x cubed plus 3x squared minus 8x plus 3. And yeah, that's fine. So Caroline, that's a new one.
Yeah, was just that the answer?
Yeah, that was it. The answer to that last one. Yeah. All right. So you got 2x cubed plus 3x squared minus 8x plus 3. So again, I'm creature of habit. So first thing I do is I look at the degree, and I'm really going to try, to give you a degree 3. And so this means I'm going to have 3 answers. Beyond a shadow of a doubt, I know that I'm going to have 3 answers. The question is, where do I go from here? Well, I'm going to go ahead and list out my rational roots. So I'm going to do my P's and my Q's. So my rational root theorem. So my value for P is 3. And then my value for Q is 2. And so what I'm going to have here is 3 over 2. And then I'm going to list my factors of that. So factors of 3 are 1 and 3. Factors of 2 are 1 and 2. And then you do your combination. So you're going to have 1 over 1, which is 1. 1 over 2, which is 1/2. 3 over 1, which is 3. And 3 over 2, which is 3/2. And then just tack on a plus or minus. So that's my list of possible solutions. And I'm going to write it out so you can see it better. So I really have 8 numbers here. 1, 1/2, 3, 3/2, -1, -1/2, -3, and -3/2. Okay? So again, if I did not have a calculator, I'd have to test some numbers. So Gracie, I'm going to let you pick. Which number do you want me to try? You can pick any one of them.
3.
Okay, I'm going to try 3. Positive 3. Okay, all right, we'll try out 3. So let's test it out. So 2, 3, -8, 3. All right, so that division, bring down the 2. 2 times 3 is 6. 6 plus 3 is 9. 9 times 3 is 18. No, 9 times 3 is 27, right? 27. And then -8 plus 27 is -19. And there's no way, because this is going to be like -357. No, that's going to be a remainder of, yeah, so that's not going to work. So that's not a remainder, so not going to work. All right, so 3 didn't work, so that's okay, that's fine. All right, Larry, pick me another number for me to try. 1? 1? Why not? Let's try 1. All right, so 2, 3, -8, and 3. All right, so then I'm going to bring down a 2, multiply, I get 2, add, I get 5. Whoa, really? 5? -3? -3? We're going to play the lottery tonight, Larry. All right, so yeah, that one works out. Yeah, so that's the remainder 0. So 1 is one of my answers. And see, once you've got that answer, and this goes back to what Angela was asking, my degree was a degree 3, which means that when you do systematic division, this is now a degree 2, which means it's a quadratic, which means this is A, this is B, and that's C. And so now we can do the quadratic formula. So -b plus or minus b squared minus 4ac all over 2a. And so I'd have -5 plus or minus -5 squared, well, no, 5 squared, sorry. Let me go back. 5 squared, not -5. B squared, so. All right, so 5 squared minus 4 times 2 times -3 all over 2 times 2. And again, you can't type that whole thing into the calculator, but what you can type is this number, which is the discriminant. And so what you get is -5 plus or minus 25 plus 24. Is that, what is that? 49? Oh, this is going to be great. 49 over 4. The reason why I said this is going to be great, don't leave it. What's the square root of 49? 7. That's right. So -5 plus or minus 7 over 4. And even more so, guys, don't leave it like that. Let's break this apart. -5 plus 7 is going to give me 2. So that's 2 over 4, which reduces to 1/2. And then -5 minus 7 is -12. And -12 divided by 4 is -3. Now, what's great about this problem, guys, if you were to plug this into the graphing calculator, I think your graph would give you all 3 of your answers, because it would cross at 1, -3, and at 1/2. And so you could have used the graphing calculator to get your 3 answers without having to do all that. Granted, if you had a calculator. If you didn't have a calculator, you'd have to do it that way right there. What you got, Nancy?
If we left it -5 plus minus 7 over 4, is that wrong?
Yeah, no, it's not wrong, but I would mark off, because the keyest thing is simplifying, so you just want to simplify it. So I wouldn't mark the whole thing wrong. No, absolutely not. And you know what I would do? I would use my graphing calculator to check and go back and confirm that my answers were right. You know what I'm saying? I'll do that. Okay. All right, I'm going to pause that right quick. Okay, here's your next one. Take a look at this one. So it's, again, another polynomial, 8x cubed minus 6x squared minus 23x plus 6. So what I'm going to do is start off by saying it's got a degree 3, so that means I'm going to have 3 answers. I know that. And then I'm going to do my p's and my q's. So p's and q's, so p over q, so p is going to be 6 and q is going to be 8. Well, this is going to be tedious. Factors of 6 would be 1, 2, 3, and 6. Factors of 8 would be 1, 2, 4, and 8, which means if I do my combinations, I'd have 1 over 1, I'd have 1 over 2, I'd have 1 over 4, and I'd have 1 over 8. Then I'd have 2 over 1, 2 over 2, then I'd have 2 over 4, and then I'd have 2 over 8. Then I'd have 3 over 1, which is 3, 3 over 2, 3 over 4, and 3 over 8. And then I'd have 6 over 1, 6 over 2, 6 over 3, 6 over 8. And then that would be it. So that would be all of them. And then put plus or minus. Now, I agree that is a lot of possible, but think about it, if you didn't have a calculator, you'd have to do it by hand. You'd have to test them out. But thankfully, we do. So I'm not even going to try to attempt to test those numbers out. I'm just going to go ahead and grab out my handy-dandy calculator, and we're going to graph this sucker and see if we can get some answers from it. So I'm going to hit tab, I'm going to go up, I'm going to clear this out, and so I've got x cubed, so that is 8. So I'm going to put in 8x cubed, and then I'm going to put in minus 6x squared, and then I'm going to put in minus 23x, and then I'm going to put plus 6, and I'm going to hit enter, and then look at my graph. How many times does the graph cross the x-axis? 1, 2, 3. Now, if you look at this one right here, I can't really tell what that is. I know it's between -1 and -2. I don't really know what this one is. It's between 0 and 1, but beyond a shadow of a doubt, what's one of my answers right there? -2, right? Not 2. Positive 2. Thank you. All right. So let me go back to the slide. So let's go back to the problem. Did it come up there? I'll go back to it. All right, there it is. All right, so -2 was one of my answers. So I'm going to go ahead and put that right. Not -2. Positive. I keep on saying -2. Positive 2 is one of my answers. So let's do synthetic division. It shouldn't be a surprise it works out, but let me put in positive 2. So I'm going to have 8, -6, -23, and 6. All right, so bring down the first number, 8. 8 times 2 is 16. -6 and 16 is 10. 2 times 10 is 20. -3, -6, remainder 0. But still, that shouldn't be a surprise because the graphing calculator confirmed it. So my remainder 0, which means that is one of my answers. And then my original degree was 3, which means this depressed polynomial is a degree 2, which means it's a quadratic. So you got A, B, and C. So I'd have -10 plus or minus 10 squared minus 4 times 8 times -3 all over 2 times 8. What you got, Brendan?
So if it's like a degree 4,
yeah,
you would have to do it twice.
Twice. That's right. To break it down. That's right. Brendan's right. Yeah. All right. So here's the thing. You can't type the whole thing into your calculator. All you can type in is this value right here, the discriminant. So I type that in. So you'd have -10 plus or minus radical over 16, and so I'd have whatever that is, 100 minus 4 times 8 times 3. You might want to double check my arithmetic, but I get 4. No, that's not a negative. That's not sorry. 100 plus 32 times 3. You get 196. Okay, double check me. 196. And I'm just curious. I don't know if there's a square root of that or not. I'm gonna try. Is it? Okay. Good. So then that works out great. So that's -10 plus or minus 14 over 16. And then again, just like Ansel said, don't leave it like this. Split it apart. So -10 plus 14 is 4 over 16, which reduces to 1/4. -10 minus 14 is -24 over 16, which reduces to, I think, -3 over 2. 8. Yeah, I think that's right. And so that would be my 3 answers right there. And that's it. That's all that you've got to do. So I know it seems repetitive, but that's all you do each time for those problems. All right. So the last thing I want to go back over is something called, there's one more thing that we learned yesterday, is Descartes' rule of sign. I say Des, but it's Descartes. So it's called Descartes' rule of signs. And that's one thing we covered yesterday. Now, I need to say this. Descartes' rule of signs does not give you the answers. All it does is it gives you the number of possible positive zeros and the number of possible negative zeros. That's all Descartes' rule of signs does for us. And so let's say I give you this example. Let's say I give you f of x is equal to x cubed plus 7x squared plus 7x minus 15. The way Descartes' rule of signs is you look for sign changes. So what you do is you count the number of sign changes. So you know that this number is positive, this is positive, this is positive, then it's negative. So positive, positive, no sign change. Positive, positive, no sign. But positive, negative, there's one sign change. So the number of possible positive zeros is 1. There's only one possible positive real zero. That's from Descartes' rule. So you count the number of sign changes. Descartes also says that you go down by 2, but if it's 1, you can't go down by 2 because then that would be a negative number. So it's just 1 possible. Now, to do the number possible negative, what you do first is you have to plug in negative x into the function. So look below here, I'm going to plug in negative x. So I'm going to have negative x to the third plus 7 negative x squared plus 7 times negative x minus 15. And just clean this up a little bit first. And so negative x to the third, well, a negative times a negative times a negative is a negative, so that would be negative x cubed. Negative x squared, a negative times a negative is a positive, times a positive 7, that's going to be a positive 7x. A positive 7 times a negative x is going to be a negative 7x, and then nothing happens with this negative 15. So to do the possible negative, you have to plug in negative x first, but then count the sign changes again. So count the sign changes. Negative, positive, there's one sign change. Positive, negative, there's one sign change. Negative, negative, there's not one. So how many total sign changes there were? 2. But Descartes' rule of signs says you go down by 2. So it could be 2 or it could be 0, right? Go down by 2. So that's Descartes' rule of signs.
What was